Hello students, in the second video of second part of Laplace transform unit, we shall see inverse Laplace transform by using partial fractions. So I told you in the topics are basic. Under the basics, we have seen the basic formula. Using basic formula, we have seen basic uh, inverse Laplace transform problems. Now we shall see about partial fractions. Okay, and here, suppose the factor is like this. P by S by some function of S by S plus A into S plus B. So if we get like this, we write like this. So A by S plus A plus B by S plus B. And we find the values of A and B. After finding values of A and B, we apply inverse Laplace transform. In the second case, this is the first case. In the second case, if same thing, the numerator some function of S, it can be constant also. Okay, S plus A into S plus B in the previous we have seen power n, square, cube, whatever. Then we do like this: A by S plus A plus B1 by S plus B, first power 1, and B2 by S plus B whole square plus B3 by S plus B whole cube, like this. And so on up to n. It can be maximum 3, power 3, 2 or 3. Okay, we can get like this. So this is the second case. In the third case, if we see some function, numerator any function or any constant, S square plus B, S square plus D. So like this. In the middle, we may or may not have this term, AS or CS term. We simply we may get S square plus B and S square plus D also. So if the middle one is optional, it may or may not exist. S square plus AS plus B, S square plus CS plus D. Then AS plus B by S square plus AS plus B, CS plus D by S square plus CS plus D. Like this, we solve this equation. Fourth form, it's not required actually. Okay. And here in this case, this is of the form. Okay. So I'll tell you in the numerator, I'll take simply 1. It can be a function of S or whatever. Okay. So function of S square plus A into S square plus B. So we take it as AS plus B by S square plus A plus CS plus D by S square plus B. Like this also we can get it. Otherwise, the middle one, the coefficient of S can be 0 or some any constant. Even though if it's not there, we can also write like the same form. AS plus B by so and so, CS plus D by so, like this. But I'll tell you here the shortcut. If the middle one is not there, then this shortcut method works. Here the middle one is not there. Coefficient of S is not there in both of them. And here we have a shortcut. Okay. So I'll tell you the shortcut. Directly we can write in the form of 1 by B minus A into, so the numerator can be 1 by S square plus A minus 1 by S square plus B. This is the shortcut. No need to find A, B, C, D values. No need to find those things, and the simplification requires a lot of simplifications, calculations and everything. But here directly we can write 1 by B minus A, 1 by S square plus A minus 1 by S square plus B. Here the thing is B is greater than J. Okay, B is greater than J. So the bigger one minus smaller one. So here first smaller one minus bigger one. Like this we get it. So if we see, so this is the thing. Suppose if the numerator is S, here also we put S. If the numerator is constant, we put whatever here we have the numerator, we write in both the places here. It can be constant or function of S. If it is S cube, something like this, S square. Suppose it is 2S. Here also we write 2S, 2S. Here also. So like this we write. This is the shortcut. If the middle one, that is the coefficient of S, is not there, then only it is possible. This is a shortcut. Okay. And let us see the first problem based on the first case. S plus A, S plus B, S plus C also. The third term may also exist. As we have learned in the intermediate level, I think everybody can easily understand that partial fraction. If we know the partial fraction, after doing the partial fraction, the problem is nothing. Just directly apply the basic formula. Okay, partial fraction is only the main thing in this type of problems. Okay, now the question is find the L inverse of s plus 2 by s into s plus 1 into s plus 3. Okay, and here the three terms are there. So we get a by s, b by s plus 1, c by s plus 3. We leave about the numerator, whatever the numerator can be, that can be constant or function of s, whatever. But we have to see the degree of numerator and degree of denominator. The degree of denominator must be greater than the degree of numerator. What's the degree of denominator? Yes, yes, yes. 3s are there. That is the 3. The degree is 3. Numerator is 1. So the degree 3 is less than 1. So we can apply partial fraction. If the numerator we figure s power 4 plus 2, suppose like this, we cannot apply this method. That only the thing we have to see. That is the only thing we have to see. The degree of numerator is 1. Here the degree of denominator is 3. So 3 must be greater than 1 like this. The degree of denominator must be greater than the degree of numerator. Then only we can apply the partial fraction. So as we have seen in the intermediate level, so simply we can write s plus 2 is equals to a into s plus 1 into s plus 3 plus b into s into s plus 3 c into s into s plus 1, c into s into s plus 1. So like this. And here we can take s is equal to 0, minus 1, minus 3. So taking 0, we get a value is 2 by 3. Taking minus 1, we get b value as minus 1 by 2. Taking s is equal to minus 3, we get c value as minus 1 by 6. This you can easily understand by seeing this solution. Okay. And substituting a, b, c values, the quotient s by s into s plus 1, s plus 3 becomes like this. A by s, what is a value? 2 by 3, 2 by 3s. B by s plus 1, what is b? Minus 1 by 2. So substituting minus 1 by 2, we get minus 1 by 2 into s plus 1. C by s plus 3, what is c value? Minus 1 by 6. So minus 1 by 6 into s plus 3. Now applying the linear property, we can take 2 by 3 outside, we get L inverse of s. And minus 1 by 2 outside, we get L inverse of s plus 1. Minus 1 by 6 outside, we get L inverse of 1 by s plus 3 using the linear property. Here the direct formula I told you now. After doing the partial fraction, the question is nothing. Okay, so what do we write? L inverse of 1 by s is nothing but 1. L inverse of s plus a is e power at, e power minus 8. Here a is nothing but 1, so e power minus t. 1 by s plus a is e power minus 80. Here a is 3, so minus 3. That's it. This is the thing. So we are going to see in this topic. Okay, this is the first problem. So we got the answer is 2 by 3 minus 1 by 2 e power minus t minus 1 by 6 e power minus t. This is the final answer. And let us see the next problem based on the second type. What's the second type of partial fraction? Power n. Okay, power n. I told you maximum we get the square or cube. Power 4 we won't get that much of bigger problems. We won't get. Okay. The question is s plus 2 by s plus 3 into s plus 1 whole cube. If whole cube is not there, just simply we write a by s plus 3, b by s plus 1. A by s plus 3, b by s plus 1. But s plus 1 power 1, c by s plus 1 whole square, d by s plus 1 whole cube. Based on the simplification, we get simply the numerator we get s plus 2. The left hand side we get s plus 2 and a into s plus 3 whole cube. Okay, s plus 3 whole cube. B into s plus 3 into s plus 2 whole square. We get like c into s plus 3 into s plus 1 and d into just s plus 3. We get like. So that's the thing. And here to solve this one, so what we take generally, we take minus 3 is on one value, minus 1 is one value. Here also we get minus 1, minus 1. So how do you find c and d values? So there are two methods in this PDF file. One method is there, the hardest type of problems here, and I'll tell you manually, that is easiest way how to solve this type of partial fraction very easily. I'll tell you. Okay, here I'll explain this one also simply. Here what you do, expand all these terms and write coefficient of s cube, coefficient of s square, coefficient of s power 1, like this. So we have to equate the coefficient of s cube, coefficient of s plus s square, coefficient of s, and constant terms. And we get 4 equations. We solving 4 equations, we get the values of a, b, c, d. Okay, but I'll tell you in a different method. I'll tell you in the different method. Okay, this is the thing I'll write here. Now the question is, the numerator we get just s plus 2, s plus 2 is equal to right hand side we get a into s plus 1 whole cube, a into s plus 1 whole cube plus b into s plus 3 into s plus 1 whole square plus c into s plus 3 into s plus 1 plus d into s plus 3. Okay, as in the previous methods we get directly, I'll take so different method. I'm telling very easy method. This is the thing. Okay, s is equal minus 3, s is equal minus 1, as it is we take. Okay, if s is equals to, first we take minus 3, so minus 3 plus 2. If we take s is equal to minus 3, minus 3 plus 2 is equals to, if we take minus 3, this, that is the coefficients of b, c, d becomes zeros. And we get only a coefficient, that is a into minus 3 plus 1 whole cube. That is minus 3 plus 2 is minus 1, and minus 3 plus 1 is minus 2 whole cube. Minus 2 whole cube is minus 2 cube is 8a. So that we get a is equals to 1 by 8. Simply we get directly a is equal to 1 by 8. We can see the answer here. So after simplification, so much of simplification, what do we get? A is equal to 1 by 8. Simply we get it. Okay. And next, as well as we take if s is equals to minus 1. So if we take s is equal to minus 1, here s is equals to minus 1 plus 2 is equals to, here if we take s is equal to minus 1, this and this becomes, that is the coefficient of a, b, c becomes zeros. And we get only the t term, that is d into minus 1 plus 3. Minus 1 plus 3. So we get what? Minus 1 plus 2 is 1 is equals to d into, what is the coefficient of d? 3 minus 1 is 2d. That is d value is 1 by 2. So you can see here the d value is 1 by 2. Still we need to find b and c values. Okay. So to find b and c values, randomly we take s value. So we cannot take s values. So that is the previous one, minus 3 and minus 1. So we take randomly. The random values are 0, minus 1 plus 1, minus 2 plus 2. But what the minus 1 is already over. So we take 0 and 1. Randomly we take any value, 100 also we can take, 100, 200, 300 also we can take, but it must be very simple. Okay, I'm taking only 2 values because how many unknowns are there still? A and C, D values we got it, and still how many values? B and C values. Since we have to find 2 values, 2 unknown values, so I'll take S values 2 randomly. I'll take 0 and plus 1. So take as low as possible. 0, 1, minus 1, minus 2. So since minus 1 is over, I'll take 0 and 1. Okay, randomly we can take in 200, 300, 1000 also we can take. But I'm taking least values so that we can solve very easily. I'm taking s is equal to 0. So 0 plus 2 is just 0 plus 2 is equals to, here since taking s is equal to 0, we get just a 0 plus 1 whole cube, that is 1 cube, plus what's the coefficient of b? 0 plus 3, 0 plus 1, 3 into 1, that is 3b plus c value 3 into 1, that is 3c plus 0 plus c, that is 3d. So here first I'll substitute the value of a. What is the value of a? A we have got it as 1 by 8, isn't it? Plus I'll take 3 as common, b plus c, because b plus c values we need, b and c values we need to find. D value we know, that is, what is D value? 1 by 2. So 3D is nothing but 3 by 2. So 3 into b plus c is equals to 3 into b plus c is equals to 0 plus 2 is 2, and taking 1 by 8, 3 by 2 to left hand side. So that is here right hand side. Minus 1 by 8 plus 3 by 2. Okay. So that the value becomes what? 2 minus 1 by 8, 3 by 2. You can use calculators to do that one. So I'll tell you 16. I'll tell you 16 minus 1 minus 12. That is 3. So 3 by 8 we get it. We can do manually or using calculator also we can do it. So we get simply 3 by 8, so that this 3 can get be cancelled. We get b plus c value is just 1 by 8. Put it as equation 1. Okay. Next again we take if s is equals to randomly what we are taking 1, 0, 1, minus 1, 2, minus 2. That least values we have to take. Since there are two unknowns, I'm taking two values, 0 and 1. Now if you take 1, 1 plus 2 is 1 plus 2. I'll directly write 3 is equals to here 1 plus 1. Here 1 plus 1 is 2. 2 cube is 8. 8a plus here 1 plus 3, 1 plus 1. So what do you get? 1 plus 3 is 4 here. And 1 plus 1 is 2 square. 2 square is again 4. 4 fours are 16. Okay. Directly I'm doing like this. 4 into 4. That is 16. So 16b plus here 1 plus 3 is 4. 1 plus 1 is 2. 4 twos are 8. Here also we get 8c plus d coefficient. 1 plus 3 is 4d. 4d. Here so substitute the values of a and d. What is a value? 1 by 8. Okay. So 8 into a value is 1 by 8. Okay. And next, what do we get? B value. B and C values we don't know. But here we can take 8 as common. 16b plus 8c. I'll take 8 as common. So we get 2b plus c plus, and we take d, 4d. What is d value? 1 by 2. That is 4d. D value is 1 by 2. 4 by 2 is equal to 3. Simplification, what do we get here? I'll write only this thing. Okay, we get 8 into 2b plus c is equals to 3 minus here 8 cancel, we get 1. So minus 1. Here 2 ones, 2 twos. So we get minus 2. So what do you get? 8 into 2b plus c is nothing but 0. So that simply we get 2b plus c is equals to 0. Put it as equation 2. Like this, randomly taking s values, 2 values, we get 2 equations with the 2 unknowns. B plus c is 1 by 8. Equation 1, b plus c is 1 by 8. B plus c is 1 by 8. That is equation 1 and 2. I am doing equation 2 minus 1. So what do you get here? Minus, minus, minus. So minus c and cancel. 2b minus b is nothing but b is equals to minus 1 by 8. See the value of b wherever show here. B is equal to minus 1 by 8. So directly we got it. And substituting b value is 1 by 8 minus 1 by 8. See here. B plus c is equals to 1 by 8. B value is minus 1 by 8 plus c is equals to 1 by 8. So that c is equals to 1 by 8 minus 1 by 8. If we take it to right hand side, we get plus 1 by 8 plus 1 by 8. 1 by 8 plus 1 by 8 is 1 by 4. C value is 1 by 4. Like this we get. So simply we can find the values of A, B, C, D. So taking coefficients takes much time. It takes 4 equations solving. Simplification we have to do s plus 1 whole cube, s plus 1 whole square into s plus 3. So like this, lot of complications are there. Using my method, so actually easiest method. This is actually easiest method. We can do very easily. Okay. And next here, after partial fraction, what we get? A by s plus 3. What is a value? 1 by 8. 1 by 8 s plus 3. b by s plus 1. What is b value? Minus 1 by 8. So minus 1 by 8 s plus 1. c by s plus 1 whole square. What is c value? 1 by 4. So 1 by 4 s plus 1 whole square. d by s plus 1 whole cube. What is d value? 1 by 2. So 1 by 2 s plus 1 whole cube. Okay. So using this one, so we can take using the linear property 1 by 8 outside. L inverse of 1 by s plus 3 is e power 1 by s plus a is e power minus 8. A value is 3. 3t minus 3t. And minus 1 by 8 outside. 1 L inverse of 1 by s plus a is e power minus 80. Here in this case, a is minus 1. Here we have to apply first shifting theorem. So these two terms I am not explaining now using the inverse Laplace transform of first shifting theorem. So these two terms I'll explain later. Okay, simplification we get the answer. These simplification I'll tell you after partial fractions. So after explaining first shifting theorem, once again I move to the second problem of in partial fractions and explain these two terms and simplification also, because you cannot understand without knowing the first shifting theorem. These two terms, last two terms, we have to apply first shifting theorem of inverse Laplace transform. Okay, and let us move to the third problem. Here, the third problem is on third type. That is some function of s by s square plus a, s square plus b. Here, in this PDF notes, they have done a lot of bigger things. I told you the shortcut now. Using the shortcut, we can do very easily. In exam also, we can use the shortcut. Okay, I'll tell you. So what's the question? S by s square plus 1 into s square plus 4. Okay, is equals to 1 by, I told you, b minus a. Here b is nothing but bigger minus smaller. Here bigger is 4, smaller is 1. The bigger is 4 and smaller is 1. Into, here whatever we have the numerator, directly write it. 1 by s square plus smaller 1, that is a, that is 1. S by, the numerator as it is, here we write s square plus 4. So the thing is 1 by 3 into s by s square plus 1 minus s by s square plus 4. Simply within the single step, we can write the partial fraction here. So after doing the lot of calculations, and simply we get what? See here, 1 by 3 outside, s by s square plus 1 minus s by s square plus 4. Same thing we get it. Okay. So in exam also we can do the shortcut. No need to do all these things. Okay. So after the partial fractions, we get 1 by 3 outside, L inverse of s by s square plus 1 minus 1 by 3 outside here. So s by s square plus 4. So directly we can apply 1 by 3 outside. L inverse of s by s square plus 1 is, what is cos 80. Here a is nothing but 1 square, that is cos 1t. Here we get cos 1t. And 1 by 3 outside anyway. S by s square plus a square. What is a square? 2 square. Cos 2t. Cos. So that's the final answer. Simply we can do like this. Okay. So this is about the inverse Laplace transform using partial fraction. In the next topic, we shall see inverse Laplace transform of first shifting theorem. Okay.